This video is nothing different than what we were doing in class, but it's a good practice to write a Maclaurin series again, and we'll do more practice in class again today. So we're asked to write the Maclaurin series for 4 to the x and then determine the radius of convergence. So we remember Maclaurin series just means Taylor series centered at 0. So our center is 0. It makes things a little bit nicer. So let's write out the general formula for a Maclaurin series, and then we'll start finding derivatives. So we have f of 0 plus f prime of 0 over 1 factorial times, this would be x minus 0, but I just write that as x to the first power, plus f prime or f double prime of 0 over 2 factorial. This would be x minus 2, or not x minus 2, x minus 0 squared. I write that as x squared. And then f triple prime of 0 over 3 factorial x cubed, and we keep going. So let's start finding derivatives and then plug 0 in. So we'll start out with our original function is 4 to the x. Its derivative, you might have to think back in your brain. E to the x just stays e to the x, but if I have any other base, this becomes 4 to the x ln of 4. ln of 4 is a constant, so it's just going to hang out there when I take the derivative. So the derivative of 4 to the x is going to be 4 to the x ln of 4 again, and then this ln of 4 will come down. So we could rewrite this as 4 to the x ln of 4 squared. The third derivative will be this 4 to the x's derivative becomes 4 to the x ln of 4. These ln of 4, the ln of 4 squared is just a constant, so it's just going to hang out there again. And then we could combine those into ln of 4 cubed. You're probably seeing the pattern here. The next derivative is going to be 4 to the x ln of 4 to the 4th. The goal when you take derivatives really is just to find a pattern or to see if you can find a pattern. So get enough derivatives until you think you can find a pattern. So now if we plug 0 into these, f of 0, 4 to the 0 is 1. 4 to the 0 times ln of 4 will just leave me with an ln of 4. So we're just going to be left with the ln pieces, ln of 4 squared. This one looks like it's going to be pretty easy to find a formula, which is nice. This is where it's good not to put this into a calculator, because if you put these into a calculator, you're never going to be able to figure out a formula. So let's go back up and plug things in. So we're going to have 1 plus ln of 4 over 1 factorial times x to the first plus ln of 4 squared over 2 factorial x squared plus ln of 4 cubed over 3 factorial x cubed. The general term then will be ln of 4 to the n over n factorial x to the n. And if we want to write that in summation notation, our summation starts at 0, and we just stick that general formula in there. Okay, and now I asked you to find the radius of convergence as well, which is why it was good to get a general term. So let's see, that one has a factorial in it, as most of these will. So I'm going to use the ratio test to find my radius of convergence. So let's see what I'm going to get here. This will be a limit as n approaches infinity, ln of 4 to the n plus 1, x to the n plus 1, all over n plus 1 factorial times n factorial over ln of 4 to the n, x to the n. Don't forget our absolute values. Okay, let's start canceling things out. The x's will cancel out and leave me with an x in a numerator. Same thing with the ln of 4s. The n, this one will be n plus 1 times n factorial. So the n factorials cancel out. So all my n's are going to be left in the denominator. So we're going to have ln of 4 times x over n plus 1. When I plug infinity in for n, I have infinity in the denominator and no infinities in the numerator. So this is going to give me 0 out. 0 is always less than 1. So this power series, this Maclaurin series, converges for all x. This one we're asked for the radius of convergence. So the radius is just infinity.